Okay, the next chapter in the Klein textbook is all about amines. And before we get too far into this chapter, I just wanted to go over some of the basic naming of these amines. So, the most basic amine that we have right here is NH3. Most of you know this as ammonia. It's one of the classic bases that we use throughout chemistry, right? It's one of the simplest, or it is the simplest amine. One thing I did want to emphasize, though, is the difference between ammonia and its conjugate acid, the ammonium ion. A lot of people use these interchangeably when we have to be really careful. Whenever we have that IUM suffix, it implies that we're dealing with a charged species here. So it's always going to be the conjugate base of ammonia. In addition to that, we have a variety of different carbon-nitrogen amines that we can name. The first one only has one carbon group attached. And because of that, this is referred to as a primary amine, because there's only one carbon. Over here, we've got two carbon groups attached, so this would be secondary. And then, as you can see, this has three, so it would be tertiary. And then last but not least, we've got four carbon groups attached over here, and this would be quaternary. The one thing to remember with quaternary amines is that they're charged, so what we call this is a quaternary ammonium salt. And again, like I said, because it has that IUM suffix, oh, that kind of looks like an L, so let's fix that. Because it has that IUM suffix, it implies that it's a charged species. And in this case, we can alkylate the nitrogen to get all the way to that charged species. All right, another term I did want to briefly bring up was the term alkaloid. And what an alkaloid means is that it is an amine that is derived from a natural source. A lot of our pharmaceutical drugs are actually alkaloids, and they're derived from plant materials. All right, so you may see the term alkaloid thrown around a fair amount, especially in biology, but it just means that it's one of these amines that's derived naturally from a plant or an animal. All right, so let's look at the really basic reactivity here. And the reactivity is pretty straightforward. And we're going to focus on the non-charged amines, so we're not going to look at the ammonium salts, at least right now. And if you have an amine, it's important to remember the Vesper shape. And in this case, I'm just going to include all three R groups, but there's a lone pair kind of sticking out in this sp3 orbital. The overall shape for these amines, when they're not charged, that is trigonal planar. Or, sorry, trigonal pyramidal, holy cow. And because of that, this lone pair over here is kind of sticking out in space, making it a really good nucleophile. So it's going to be a good nucleophile, and it's also going to be a good base. We've seen nitrogens used as bases a lot in general chemistry, specifically ammonia, and it's because nitrogen, when it has that positive charge and forms its conjugate acid, it's somewhat stable. It's not as stable as some other species, but it's relatively stable. So if we treat it with an acid, some sort of proton source, this lone pair can grab that proton, and we can make our ammonium salt. And when we make this ammonium salt, it's important to remember that the Vesper shape changes, and we go from trigonal pyramidal to just our classic tetrahedral. Additionally, we can do SN2 chemistry as long as this R group right here is unhindered. If it's an unhindered R group, meaning like a methyl or primary carbon, then we can do this SN2 reaction where we do the backside attack on this unhindered carbon, and we kick off our leaving group. Again, we can use this to make a variety of amines. However, as we'll see in a little bit, it's really, really hard to not overshoot, and so we often are stuck getting this quaternary ammonium salt. We can't just add in one group through the SN2 reaction. It kind of runs away from you there. All right, so now let's take a look at the nomenclature. The nomenclature is pretty straightforward. And it's pretty much the same as alcohols, but we're going to change our suffix. So let's make a note. It's the same as alcohols, but instead of the OL suffix, we're going to replace it with amine. So we're going to replace that OL suffix with an amine suffix. So let's take a look at a few examples. Let's say we have this amine right here. Well, we first want to identify our longest carbon chain, which in this case is going to be 2 carbons long. So it's an ethyl group, or ethane, as our parent backbone. And so what we're going to name this is ethylamine. In this case, we are going to include the Y. Sometimes you might say, well, why isn't it ethanamine? I don't really have a good answer for that, besides it just flows off your tongue better to say ethylamine. I think ethanamine is technically allowed, it just sounds funny. All right, let's do another one. In this case, we've got an isopropyl group, so we could call this isopropylamine. Or if you want to change the naming system, you can identify the longest carbon chain. And we could say, well, the amine in this case is coming off of carbon 2. So we could call this 2-propanamine. And that would also be IUPAC allowed. If we have something like a cyclohexane with an amine, then we just call this cyclohexylamine. And then we've also seen some aromatic amines in our previous chapters. Specifically, we saw an aromatic group with an NH2 off of it. And as you recall, we just call this aniline. All right, so now let's work through some practice problems with naming and spend a little bit more time working on it. And these might get a little bit more complicated. So the first one I want to do looks like this. In this case, we've got 2 different functional groups. However, the tricky thing is the ketone is actually more important when naming than the amine group, meaning this gets the suffix. So the suffix is ONE because that ketone is higher priority. Okay, so let's go ahead and try to name this. Well, in this case, the longest carbon chain containing our functional groups is going to be 3 carbons. And we've got this NH2 group coming off of carbon 1. Because it's no longer the most important functional group in our molecule, we're going to call it an amino substituent. So this would be called 1-amino 2-propanone. And so if you ever have more important functional groups in your molecule besides your amine, it is important to remember that you need to treat them as a substituent and call them an amino group. Just like we would with alcohols, we would call them a hydroxy group. All right, let's do another one. In this one, we're going to have 2 different groups coming off of it. And we also have 2 stereocenters, right? So let's just do our stereocenters first. If we look at this stereocenter, it's going to be an R. And if we go over here and we look at this stereocenter, it's going to be an S. So we'll try to throw in some stereochemistry as well. The longest carbon chain is going to be 1, 2, 3, 4, 5, 6, 7. And the reason I numbered that way rather than going the opposite direction is we want to put the amino group at the lowest priority. It's the alphabetical tiebreaker in this situation. So let's go ahead and name this. It's going to be 3s, 5r, 5-methyl, 3-heptan, and then our suffix is just going to be amine, indicating that that's our most important functional group. All right, now let's try a slightly more complicated one, and this is one that we saw a little bit when we did our amide naming, and that is, what if you have substituted nitrogens? So in this case, my nitrogen has 2 CH3 groups coming off of it. Well, again, I would first focus on my stereochemistry. It's easy to do. So that's an S stereocenter. Then I would identify my longest carbon backbone that contains the bond to nitrogen. So in this case, it'd be 1, 2, 3, 4, 5, 6. So we've got a 6 carbon chain. And so now what we need to do is we need to figure out, well, how in the heck do we name these? Well, if you want to name the lower priority substituents coming off our nitrogen, meaning not the parent carbon backbone, but some other substituted groups coming off your nitrogen, you first need to label them like this. So you do N, N to indicate that there's 2 groups coming off of the nitrogen. In this case, each of the groups are methyls. So I'd say NN dimethyl. And this whole group is coming off of carbon 3. So I'd say 3-hex-an amine. And last but not least, we'll throw in our stereochemistry. We've got our S stereocenter, and we'll plug that in the front. So it is important to remember that if you have groups coming off of your nitrogen, you have to put the N twice. Just like we would with our numbering scheme, if you have 2 methyls coming off of carbon 4, you'd say 4, 4. In this case, we're saying N, N to indicate that the groups are coming off the nitrogen twice. So we'll just make a note here that both methyls are off of the same nitrogen. All right. So we're going to hold off right there, and then when we come back, we're going to take a look at how to prepare amines.